When finding the equation of a quadratic function from its graph, you kind of want to use all of your information, okay? Have like your y-intercept and your equation of axis of symmetry. If the graph crosses the x-axis, or set the y-axis, where the vertex is, you want to use all the information to write your equation, okay? So we're going to look at this very first example of this quadratic here, okay? We're going to find the equation. Now we got a few pieces of cubic x. We're going to find it in standard form, okay? Which is what? What's standard form?
ax plus by equals c equals 0. I mean plus c equals 0.
That is
X
squared.
X squared
Plus bx.
plus bx
Plus c.
plus c. Yes.
That's what I meant.
Very similar. Just make sure it's a square. So, you have this quadratic. Tell me, what do you know from this quadratic? Anything? Yes. So that means that A has to be positive. That's for sure. Okay? That A is positive.
Vertex -2, -9.
-2, -9. Yes, be careful. These go by 2s.
Cross the y-axis at -5.
Cross the y-axis is -5, so that means that I have a y-intercept of 0, -5. Anything else? Okay. To piggyback off the vertex being at -2, -9, the vertex is there. We also know the
Axis of symmetry.
is as what? Is -2. What equals -2? X equals. So we pulled out all that information. We're going to use, maybe not all of it, but we are going to use probably a good amount of it to help us write our equation. Okay? Now, when it's in standard form, what does the C represent? Y-intercept. So we already know that's -5. So already we have found 1/3 of our equation. The C is -5 because that's always where the graph crosses the y-axis. So we can use that. Okay? Now to find A and B, we already know A has to be positive, and we do have to find B. And it's going to involve a little bit of thought here. So so you were trying to say an equation when I asked you for the axis of symmetry. What's the equation for the axis of symmetry? Negative b over 2a, right? X equals negative b over 2a. Right? Okay. Now, we already know that the axis of symmetry is -2. So what we can do is we can actually plug that in and set it equal to negative b over 2a. Follow me here. All right. Now, if I wanted to solve for one of my variables, how do I get rid of this denominator? Multiply it. And 2a times the -2 is a 4a equals negative b. And then since both of them are negative, technically, they cancel out. So I basically have 4a equals b. Now that I know you're probably like, well, that really didn't help us, but it actually did. Because if we look back at this line here, this second line, we have two variables. I'm not counting x and y, but I have two variables that I need to find in one equation. And usually when that happens, we need like another equation to do a system, okay? But if we're able to get one variable in terms of the other, we can actually take that and plug it in. Stay with me. I'm going to replace b with 4a. Because now, instead of having to find my two variables and they're both in one equation, I now just have one variable in my equation that I need to find. And once I find a, I can plug it back in down here to find b. So, how do I find a? Yes? Question?
We have two variables, x and y.
Well, x and y, yes, they're like the variables of our general equation, but here in the sense of trying to figure out what a and b are, they're more like points. They're like the x and y that are on my actual quadratic. Now I have 3 points that you guys gave me that are actually on my quadratic. You gave me the 2 x-intercepts and the vertex. I can use any one of these 3 to plug in for x and y to find a. Which one do you want to use?
1 and 0.
1 and 0? Okay. So if I use 1 and 0, I can use any of them and I'll still get the same answer. I'm going to plug 1 in for x and 0 in for y. And we can do this because if this is a point that's on our quadratic, it's going to work out. It's going to give us the value of a. So I'm going to plug 0 in for y, 1 in for x, and I'm going to solve for a. One squared is nothing but 1, so I have an a plus a 4a minus a 5. How do I solve for a? Add 5. And then? No, not 5, not subtract.
Add the a's together.
Combine like terms, what's a plus 4a?
5a.
5a. So then to actually find a, I need to, which is 1. A is positive, so that verifies the whole pointing up thing. And if a is 1, b is 4. There's my equation. Y equals, or f of x equals, 1x squared plus 4x minus 5. Questions? How can I confirm that this is right? Calculator. Graph it. I have an equation now that I think should match up to this. If I go to my calculator and I graph this, I should have a graph that points up with the vertex at -2, -9, and x-intercepts at -5, 0, and 1, 0. Go ahead and do that. So what say you? We got a vertex at -2, -9, and x-intercepts are at -5 and 1. Good stuff. Questions? Alright, let's look at an IB problem. Taken from the 2013 IB exam. It says the graph of the quadratic function f of x equals c plus bx minus x squared intersects the y-axis at the point A, 0, 5, and has a vertex at B, 2, 9. Okay? So we have a picture here. It shows us, it confirms that A is negative. Got my y-intercept, 0, 5. Got my vertex. If my vertex is at 2, 9, I also know my what?
Axis of symmetry.
Which is located where? At 2. Okay. So now let's get to my question. It says write down the value of C. What does C represent in this equation? The y-intercept. Where's the y-intercept? The 5. So C is equal to just 5. Because we're thinking in the sense of our equation. Hence, it said write down. Whenever it says write down, remember the answer is staring you somewhere on that page. It's in your face. Now it says find the value of B. Well, B is up here. Gotta find that value. Any suggestions?
Well, you know, like what x equals 2, so you put 2 equals -b over 2.
2A. Sure can. I can use the axis of symmetry formula, -b over 2a, because this b is the same b that's in the equation. I know that's equal to 2. I'm looking for b, and unlike the other problem that we just did when we didn't even know what a was, we do know what a is. What's a? It's a -1. Does everybody see how A is negative 1?
No.
Okay. Well, the equation right here is C plus BX minus X squared. This is basically standard form just written backwards. So if I wanted to write it forwards, where it's AX squared plus BX plus C, it would have been a negative X squared plus BX plus C. Okay. Yep. So, let's see. 2 times a negative 1 is a, and right here 2 negatives make a positive. And so B is going to be 4. Because you multiply both sides by 2. How do we find the x-intercepts of the graph? Because now I have my equation, guys. I have negative x squared plus 4x plus 5. I have my equation now. How can I find the x-intercepts? Oh, yeah. Yeah, that's smart. I can plug in 0 for y, and then
Quadratic formula.
I can use the quadratic formula to find my x-intercepts. Y'all remember what it is?
Negative b plus minus square root of b squared minus 4ac over 2a.
Yes. All right. So use the quadratic formula to find my x-intercepts. Do that now.
0 and 5, 0.
So yes, using the quadratic formula, you would have got negative 1, 0, and 5, 0. Awesome. Now it says to write down the form of f of x in this form. It says negative x minus p and x plus q. What form is this? It's the factor form. And what do p and q represent? X-intercepts. Didn't we just find them back up here? So basically, p and q are the values of your x-intercepts. So, I mean, there it is. There's the write down again. You just found the answer. It's right there in part C. So the equation is going to be f of x equals negative x minus 5 and x plus 1. And again, the reason why it's like this versus a positive 5 and a negative 1 is because, think about it, if you had to set this equal to 0 to find the x-intercepts, you would have had to do the opposite of what's on the inside of the factor. So you would have had to add 5 to get a positive and subtract 1. So it needs to be a positive and then a negative. Yes. It could be, yes.
Could you do the calculation to like find the negative or no?
Yeah, you can.
Okay.
Real quick, I want to show you how to find your x-intercepts using your calculator, okay? So everybody pull out the calculator. And I want you to type in the function into your calculator. Negative x squared plus 4x plus 5. Okay? And I'm going to do mine a little differently. There is a feature in your calculator under second trace that allows you to find your x-intercepts. It's called 0. I really don't like it because it takes a lot of time, and if you mess up, you got to start over, and a lot of students have an issue when you have to go to the left and to the right. So I kind of do it an easier way. I plug in the equation to y1, and I plug 0 into y2. Because essentially, that's what we have here. The left side of your equation goes into one of them, the right side of your equation goes into another one. We're trying to figure out when y is equal to 0, so why not plug in 0 for y? So this way, when I graph, and it's going to be easy to see on mine because I have 2 different colors, maybe not so much in you guys.
Oh, sure.
But here's my quadratic. And then here's the line y equals 0. And you're just finding the 2 points where they intersect. And we talked about that last class. How do you find out where 2 curves intersect?
Second trace.
Second trace. 5. And you can just go closer to that intersection point and
Push under 3 times.
1, 2, 3.
It's always 3.
It's always 3. Negative 1, 0. There it is.
That's great.
How do I get the other one? What do I do?
Same thing, but to the right.
Same thing, second trace, go to 5, and move closer to 5. Doesn't have to exactly be on it, just click enter 3 times. And there's the other one. Okay? That's how you can do use your calculator. Make sure you plug in